Hi, so in this video, we are going to talk about EtherChannel, both layer 2 EtherChannel and layer 3 EtherChannel. So, excuse me. So EtherChannel is a port link aggregation technology, which means it basically takes a bunch of links and treats it as a single port or bundle, or what we call a port channel. It operates at both layer 2, these links here, and layer 3, and we're going to do both of those here. So yeah, let's get started. So the first thing that we're going to look at is the layer 2 ether channel. So looking at these layer 2 switches, we can see two here, across here, and across here. Okay, well, we'll notice, first of all, by looking at the link lights on Packet Tracer, that one of the links has an amber light. Okay, that's because spanning tree is blocking that loop. Loops are bad in layer 2. They're great for redundancy. If one link goes down, the other link will, if this link here goes down, the one that is forwarding has both two green link lights. If that goes down, then this link here will come up. This will go green eventually after spanning tree converges, and this link will be used. But right now, this link is not being used. Let's take a look at a few things first. So I'm on that switch there. I'm just going to do simple show running config. And what I want to look at is I'm going to look at the fast Ethernet 01 and 02 links. Okay. So I can see, maybe if I stretch this out, that helps a little bit. I can see that I have both those ports are configured as trunk links, which is, they can be trunk links or access links, doesn't matter. Okay. But as far as the configuration goes, hey, they're ready to go. But spanning tree is only going to use one of those ports. Let's take a look at the current spanning tree state. Now, by the way, for those of you in my class or doing this on your own, your amber light, wherever it is, may differ. Okay, and I talk about this in my lecture, and I'll maybe do a video on this, but that's because spanning tree, and it just depends on where that root bridge is in our local area network. Another topic, but we'll talk a little bit about spanning tree right now. So let me do this command here. I'm going to do show spanning tree, get that out of the way. Show spanning tree interface, and let's look at fast Ethernet 01. Okay. So I'm at this switch here. I'm looking at this fast Ethernet 01 link right here, and we can see it's forwarding. Now it's forwarding for all VLANs. So we use Cisco defaults to per VLAN spanning tree or rapid spanning tree. So anyways, what you want to see is, notice here is that it is forwarding. Okay. Let's take a look at for fast Ethernet 2, what state it is in. So I'm just going to use that same command, change that to a 2. And yes, this port is also in the forwarding state. Okay. Well, what would happen if we took a look at access 1-3? Let's take a look. Okay. So I'm going to give that same command here. Show spanning tree. Interface FA01. So I'm going to look at, I'm on this bottom switch right here, FA01. I think we expect to see forwarding state. That's the green link light. Forwarding means it's going to send and receive Ethernet frames. Let's take a look at that same switch, that bottom switch, but look at fast Ethernet 02. And you're going to see that it is in the blocking state, or what we say the alternate role. But the blocking state, don't worry about roles. We talk about that in spanning tree. But blocking state, what that means, it is not forwarding or receiving. So the Ethernet frames between access 1-3 and access 1-1 are only going over the fast Ethernet 0 ports on both switches. Sure would be nice to be able to utilize both of those links, wouldn't it? Well, that's what we are going to do here in just a moment. That's what spanning tree, excuse me. That's what Ethernet EtherChannel is going to provide for us. Let's look at one more thing before we get there, though. I'm going to do show interfaces trunk. And we're going to see that it is a trunk link. Okay. And notice that it is as far as 802.1q says, I can trunk over both of those because we configured it, right? Actually, I'll go over here. When we looked at it, at least on Fast Ethernet 0.1, where was that here? Yeah, there it was. And it's the same on Access 1-3. When we looked at it on Access 1-1, excuse me, we're configured as a trunk link. Matter of fact, I could show that. Might as well just show it. Since I'm here, yeah. So we configured both those interfaces for trunk link. Now spanning tree is just blocking that port. All right, so what we are going to do is we are going to configure EtherChannel. So what I'm going to do, let's go on Access 1-1. We'll start there. Going to go in global configuration mode. Okay. The first thing I'm going to do is I'm going to give the command port channel load balance, and I'm going to use source destination IP address. Okay. Now I'm not going to get too deep into load balancing here, but this command configures load balancing for the links, how it's going to decide which link to use. We're going to use both source and destination IP address, the combination of the two. Just so you know, EtherChannel does not load balance equally across all links. It uses a little hashing algorithm. I won't go into that here. All right, next thing I want to do is let's see, configure the ports that we're going to use for EtherChannel. So I'm going to do interface range FA. How do you spell FA? There we go. FA 0.1 to 2. Fast Ethernet 0.1 to Fast Ethernet 0.2. Yep. All right. Now, this is what I like to do. Anytime I make big changes on ports, for example, changing them to what we're going to see here is a port channel moment, I like to do a shutdown. Right? I just think it makes things much more cleaner, shuts everything down. You do your configuration, and then you do a no shutdown, and you'll see at the end here, and then everything comes up, I think, a little bit more gracefully. So going to do a shutdown here. Okay, so you can see the link lights went red there. Okay, the next thing I'm going to do is I'm still in this interface range, and I'm going to say channel protocol. So is that enough? Yeah, there we go. Channel protocol LACP. Okay, so what this command does is it sets the link aggregation control protocol LACP as the protocol that's going to be used to negotiate the Ether channel. There's another one that we can use called PAGP, which port aggregation protocol, which is Cisco proprietary. But it's always nice to use the standard whenever we can. Okay, so I'll hit enter there. Okay, next thing I'm going to do is say channel group 1 mode active. Okay, what this is doing is this command assigns the selective interfaces, which is Fast Ethernet 0.1 and Fast Ethernet 2, to a channel group number 1. We're going to see in a moment that's going to be called port channel 1 in a moment. Okay? But what it does is it sets the interfaces to channel group number 1 and sets them actively to negotiate the LACP Ethernet channel with the other switch. Active right here. What that means is that the port will initiate negotiations with the remote switch to form the LACP Ether channel. And we're going to do it on both ends. So what you're seeing here we're actually going to do on both ends identically, actually across all pairs of our layer 2 switches. Okay. All right. Think we're good there. All right. Now, what I like to do to avoid inconsistencies is I like to do it on both sides first, all these commands we just saw, and then do a no shutdown on both. So I'm just going to pause here for a moment. I'm going to show you about what I'm going to do. Okay, let me get to access 1-3 here. Let's just do that one manually, and I'm going to show you an easy way to do all of this. Okay, so let me go into config T, interface. Let's say no, config T. I'm going to first do the port channel load balance source destination IP. Great. Next, I'm going to say interface range FA01 to 2, just like we did above, or for the other one. There we go. I'm going to do shutdown, although it is in the down state right now because the other end is down, but we're going to do a shutdown. Okay, and see that administratively down. Okay, channel protocol, just like the other one, we get to LACP. And channel group 1 mode active. Okay. All right. So I've done that on both. Okay. But the only thing that's left for me to do is I'm still in the port range for both, right? The only thing left for me to do is the no shutdown. So let me do a no shutdown on each. No shutdown. No shutdown. Okay. All right. It's going to take a couple of minutes here to for the port channel to come up, spanning tree convergence. So it's going to take a moment here. So let me pause the recording. And right now you're seeing these are red. They're going to, there we go. They're going to go amber and kind of go back and forth a little bit with the green and the amber. But I'm going to pause the recording here. Okay, it looks like we have all green link lights. It kind of goes back and forth for a couple of minutes, but it looks like we're all set. So before we do any verification on these, okay, what we're going to do is I'm going to do the same thing on all these other 3 pairs of switches. But Rick's a little lazy, so I'm going to show you. It's actually not lazy. This is a good idea. This helps you from making mistakes. It's always nice to make these commands sometimes in a text editor, and then you can just copy and paste them in. So especially when you have the same commands in multiple switches. So you can see for all, I'm going to go into global configuration mode, load balance. It's the same range of, down, same range, fast Ethernet 1 to 2. Rick made his life easy. Shutdown. Okay. Channel group protocol LACP. Channel group 1 mode active, etc. Then we'll do these after we do this on all of them. So let me just show you. So what I'm going to do is copy. Okay, so I've copied that, right? Let's go into each switch. And I'm already here in privileged exec mode. I just do paste. Down here, I do paste. Boom. Boom. Look at this. So easy. I was going to pause the recording, but you know what? I don't even have to. Now it's just all in shutdown, right? And one of the things you always want to check, I should have checked on the very first one, make sure you didn't make an error. Okay, that everything looks clean there. Okay. All right. So that was easy. That wasn't too bad, was it? Okay, now what I'm going to do is do the no shutdown. And I usually like to do copy run to start too. You know, maybe that would end and then copy run to start. But we don't need to do that, do we? I'm just doing end. So I'm just going to do, by the way, if you do copy run to start, I usually have a couple of blank lines there. So it takes these as the confirmation that you're copying, confirming the copy run to start command. So I always use a couple of blank lines. Okay, but let's just do this. Copy. Okay. I'm just going to move that out of the way. And let's do the same thing. Paste. 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 And paste. It's going to take a while for all of this to come up. In a moment, I'm going to pause the screen, but I just want to mention what I just did. You know, we used to think of this as kind of an early way of scripting or automation. We have new ways to do these kinds of things. And hopefully I'll be talking about these in future videos. Matter of fact, a little shameless plug here, writing a book right now with a friend of mine at Cisco on automating with NetMiko, Napalm, and Nornir that will do many of these things. So just knowing just a little bit of Python and a little bit of Cisco iOS. Maybe by the time you're watching this video, maybe the book's already been out. Okay. So I'm going to move this out of the way. You're going to see it's taking a moment for everything to come up here. So let me just pause the screen, pause the video. Okay, so you really do have to wait a good, probably 2-3 minutes, maybe longer sometimes. Looks like these links come all green and then you're ready to go and then you'll see, no, wait, they went amber again. So yeah. Now you'll notice I put these little circles here. Okay, this is very common practice. What this means is a port channel. That's what that indicates. And you can go up here to the drawing tool and make those right there. So I'm actually going to remove this kind of, let's see, remove that secondary toolbar out of the way. There we go. All right, let's take a look at what we have. So what I'm going to do, go here to access one. Let's get this one out of the way here. Okay. I'm going to do a show running config. So let me do a end here. I'm going to do show running config. And we're going to see something new here. Right there. See this? Interface port channel 1. That's what we created. Port channel 1. Okay. But there's something that we need to do, and I'm going to talk about that in just a moment. Yeah, as a matter of fact, let me talk about the port channel first. So port channel interface, that's what we did. That was that channel group, that command that we did previously. The channel, what was it? Channel group 1 command in the interface, channel group 1 mode active. Okay. So let's talk a little bit about what a port channel is. A port channel is an interface. It's a logical interface on the switch that represents the EtherChannel itself. EtherChannel aggregates, puts together the individual physical ports, in this case, or physical links, in this case, Fast Ethernet 01 and 02, in a single logical link. Okay. So this created the port channel. Sometimes also when we use the channel group command. So this means that this port channel interface, port channel 1 interface, now represents the aggregation, the combination of both Fast Ethernet 01 and Fast Ethernet 02. And any configurations applied to the port channel now apply to traffic across both interfaces. So with very few exceptions, changes to, when we want to make changes to this ether channel, okay, we usually want to do it here on the port channel and not on the physical interfaces. Now, saying this, Packet Tracer has a little bug in it. Okay, so let me talk about that. So I just did show run, and we see the port channel. What it did not get is this here. It did not put this in the port channel, and it should be there. So, matter of fact, if I do show interfaces trunk, bigger here, you'll see what I mean. See this here? First of all, show interfaces trunk. Now, it no longer shows for the trunk link. It doesn't show fast Ethernet 01 and fast Ethernet 02 as it did previously. Matter of fact, I don't know if I can go up there and we can even see that. Did I show that earlier? Thought I did. Maybe I didn't here. Okay. But anyway, this would normally show as without the port channel, fast Ethernet 01 and 02 here. Now it shows as a port channel. But look down here, VLANs allowed on the trunk. Okay, it's saying it's allowing all VLANs by default. Okay, what it didn't take, which is fine, but since we did the switch port allowed the trunk allowed VLANs, really this should have been, this is a Packet Tracer bug. I love Packet Tracer, stuff happens. Okay, so let's just make it look like what would happen on a real device here. So very simply, all we're going to do is this: interface PO1, port channel 1. So I could also just say, oh, I'm going to be in config mode, global config mode, don't I? Interface port channel 1, or just PO1. Okay. And then the command I need to give is I need to say switch port trunk and give the allowed VLANs. So I'm going to do that here. Let me just paste that in. Okay. All right. And when I do that, I'm going to have to do it on all the switches. Show you how to do that real easy, real quickly here in a moment. So I do show run. And now, yes, so this looks better. It has this in there. That's what you would see on regular iOS. And if I do show interfaces trunk, I should see it there as well. Yes, that's what I want to see. Consistency. Okay. All right, so to make this easy, let me show you what Rick is going to do. Okay. So what I'm going to do is I'm going to go back into, let me bring this up here. That. So what I'm going to do, again, use a little text document here, give myself a little room. I'm just going to paste that in. So I'm going to go in every switch. Config T, interface port channel 1, switch port, a little bigger so you can see it. There we go. Switch port trunk allowed VLAN, and end. Okay. So copy. It's going to do that on each switch. Same thing. In fact, I don't even have to pause the recording, do I? Okay. Now, at this point, if I was working on the lab here, I'd probably want to do copy, run, start. Okay, and maybe save my Packet Tracer file. Okay, so that's probably a good idea too. Okay, so you don't lose anything. In fact, you may want to do that right now. Just go to each one, copy, run, start. You could even just kind of copy that right from there, right? Let me show you what I meant by using the this here. See, watch what happens. I kind of grab a couple lines there. Hopefully you're finding this helpful. Okay, let me show you. Did it on that one there. Let's go here. Okay, well, just paste there. See, it then when it says confirming, wants me to confirm the destination file name, I've got those spaces. Okay, makes it easy. So you just go to each one. Okay, all right. Let's move forward here. Again, I've mentioned I use these little ovals here to show that that's a port channel. Now let's verify. Notice we have green link lights. Let's take a look at spanning tree. Let's go down here. Remember, this was an amber link light before. Let's take a look at this one. Both ports. Let's go show spanning tree. Interface. We'll do both FA01, all forwarding, FA02. Now, these were blocking before. Okay, now it's forwarding. So that looks really good. Okay, now I can also, this is a port channel, so I can also do this. Show spanning tree interface, port channel 1, or just PO1. Okay, so now it's showing it for the entire port channel. All right, I do want to mention a little bit about spanning tree, just a note on packet tracer. Sometimes it's a little iffy, okay? And nothing against packet tracer. You know, they do a fantastic job. Thank you, Dennis Frezzo, for all your work on that at Cisco. I also want to, let's take a look at some commands here to verify EtherChannel. Okay, so let's do show EtherChannel. And we can take a look at a few things here. Here's our group. That's our port channel 1 that we did, group 1. Okay, L2 telling me this is a layer 2 Ether channel. We'll do layer 3 here in a moment. Maximum number of ports. This is how many ports I could have. I could have actually 16 links. Okay, I have 1 port channel. Okay, going on, and the protocol I'm using is LACP. Link Aggregation Control Protocol. All right, let's do another one of these. This time, show EtherChannel summary. This is one of my favorites. Shows me some good stuff here. All right, so show EtherChannel summary. Here's the kind of the legend there of the flags that it's showing here. But let's take a look at what it shows here. So I have number of channel groups in use, just 1. Okay. This is some good stuff here. Channel group 1, port channel 1, SU. Okay, so we got to look at these here. S, capital S. Where's capital S? S, that means it's a layer 2 Ether channel. U, that means it's in use. That's what we want to see. Protocol LACP. Here's the ports that we're using. And P, what does that P mean? Okay, that means it's a port in channel. All of this together means it's looking good and it's working. Okay. All right. Another one is show EtherChannel port channel. This gives us a little bit more detailed information, some of the stuff that we saw before. Okay. But this is where we can get a little bit more information, not so much on packet tracer, but more on live equipment. Okay, so including things like the age of the port channel, the index load, things that it can use some stuff for load balancing. Won't go into that here. All right, we are looking really good. Oh yeah, let's do another one here. Close that so soon. Show EtherChannel load balance. Okay, so it tells me that I am load balancing source destination IP address. So for IPv4 and IPv6 packets, it is using source and destination IP address it's using exclusive OR. I won't go into the hashing here, but it actually is quite interesting. For non-IP traffic, like ARP requests, right? ARP and some other things. Okay, it defaults to source and destination MAC addresses. All right. That so far so good, right? Well, you know what? There's probably, well, we'll do this at the end. We'll verify everything's working by doing some pings and stuff. But right now, everything is looking pretty good. So next, what we are going to do is layer 3 Ether channel. Yes, we can actually, and this works on routers as well as layer 3 switches. Okay. What I am going to do is I am going to make another link here. Okay. Between these two layer 3 switches. Okay. But you know what? Before I do that, what I like to do is, I like to shut down that port first. Okay. And we're going to do that. So let's see, before Rick even gets into that, Rick's kind of all over the map here right now. Let me close these. There we go. So it happens, I do these live for you. All right, let me do a few things here. Let's do show IP interface brief. Let's see what we have before we start shutting out everything down here. Okay, let's take a look. Down here, there's our gigabit 1023 routed port that we did in the other lab, right? If I do show IP route, there's our switch virtual interfaces, in case you noticed that. There's our directly connected. Yeah, I'm glad I did this. I want you, because we're going to mention this when we do the port channel. Directly connected. So this is directly connected on gigabit 1023. Okay. All right. So I said what I like to do is shut things down first. So what I am going to do is actually we're going to use gigabit 1023 and the next port over 1024. So I'm going to do config T interface range gigabit 1023 to 24. Do that right? I think so. And I'm going to shut it down. Okay. I'm going to do the same thing on distribution 2. That up a little bit. There we go. Do the same thing on distribution 2. Config T interface range gigabit 1023 to 24, or not 35, 24. There we go. Okay, same thing, shut down. Okay, like I said, when I make really significant configuration changes to an interface, I usually like to put it in shutdown mode first, if that is possible to do. If I'm not kind of doing something, usually, well, production, you should try and do this as well. All right, so now let's go ahead and let's add that link that I started to do. I'm going to go from gigabit 1024 to 1024 here. And just to kind of put here, and guess we're going to make this a port channel here in a moment. Just and 24. Okay, there we go. Push that up there a little bit. All right. So let's go ahead and configure a layer 3 port channel. Let's go to distribution 1. Okay, so exit. I'm going to exit out of this. I'm at global configuration mode. Remember, we had an IP address on gigabit 1023, right? I got to remove that. Okay, because we're going to put the IP address actually on the port channel, the bundled link. So I'm going to say, I'm going to type it, interface gigabit 1023. I'm going to type say no IP address. Remove that IP address. Okay, exit. Now I'm going to create the port channel. Interface port channel 2. I'm going to call this one 2, just kind of keep them separate. It doesn't have to be since there's no port channel 1 on it, but port channel 2. Now, this port channel, this bundle, this is going to be a routed link group of ports, just like we did here. So I'm going to, just like I would on a physical interface, I'm going to say no switch port. So I'm configuring this just like a physical link. No switch port, IP. I'm going to give it the IP address, and I'm going to give that IP address, right? The 10.222.100.1. It's going to belong to the entire port channel. 10.222.100.1, 255.255.255.252. Okay. Okay, we're going to go ahead and do a no shutdown on the port channel. Not that we don't really need to, but I always like to do that. The link is still down. Physical ports are still down. The gigabit 1023 to 124. Let's do an exit. Now let's go into the range of ports. Interface range. Gigabit 1023 to 24. Did I do that right? Gigabit range. Yeah, I think that looks like gigabit 10/ yeah. Okay. Now I'm going to say no switch port. Okay. Just put it in line with this. Now, the only thing I really need to do here, similar to what we did in layer 2, channel group, channel protocol first. Channel protocol, LACP, the negotiation protocol. And then I'm going to say channel group, and this is where I give the port channel. This is where it gets its port channel number. I'm going to put a 2 here instead of a 1. Mode active. Okay. Let's do this. Now, before I do a no shutdown here, okay, I'm going to do the same thing on this switch. And I'll do it with you here live, so you get kind of used to these commands a little bit again. Okay, interface gigabit. So what we are configuring here right now is this switch up here. Okay, the .2. Okay, interface gigabit 1023. Again, we have to remove the IP address because it's not going to be on that physical port anymore. Exit. Okay. Next, let's do the interface port channel. Interface port channel. It's going to be port channel 2. It doesn't have to be the same on both sides, but best that we do it. Best practice. Okay. No switch port. It's going to be a layer 3 routed port, not a layer 2 port. IP address. Here's the other end of our link. 10.222.100.2. 255.255.255.252. Looking good. No shutdown. We're almost there. Exit. Now all we have to do is the physical port. Tell it what port channel it's on. So bind it to the EtherChannel. Interface range gigabit 1023 to 24. Okay, I think I got that right. Yeah, I think so. All right. Again, no switch port, routed port, and now let's make it bind it to that port channel. Channel protocol, LACP, same negotiation, channel group 2, mode active. And then we are all but done. What I mean, all but done. Okay. Well, I think all that's left now is to do the no shutdown on both. All right. So let's go ahead and do that. And you're going to see these link lights begin to change. Let's do a no shutdown. Okay, see, by the way, I'm in the physical port. We did that shutdown on those earlier on. Okay, so I'm still in that physical range of the ports. Let's do the no shutdown there. Let's do the no shutdown here. Okay, and then we should start to see these link lights changing. Okay, so I'm going to pause the recording here as this takes effect. Okay, so another little bug in Packet Tracer. The link lights don't all go green. I've had different, either both sides are amber, excuse me, or one side is amber like I have here, one side is green, but we'll test it. That just, you know, they do a fantastic job, you know, so it's just not always easy to catch everything. So I've also put a little circle here showing that we have another port channel, layer 3 ether channel. Okay, let's take a look at distribution 1 and let's do a few commands here that we did before. Similar command, show ether channel. This time we're doing it on distribution 1. And because we only have the layer 3 ether channel, it's showing us our group 2 there. That's channel group 2, right? L3, not L2. Again, 16 ports, max, LACP. Sounds good. All right, let's do maybe a summary on that. So it's always a good command. A lot of good stuff here. All right, channel group 2. There's our port channel 2. We'll do a show running config, and we'll see that in a moment. RU. Okay, R means it's layer 3 port channel. U means it's in use. LACP, our negotiation. There's our 2 ports in use, and they are both P, which means, where's P? There it goes, port in channel. All right, good stuff there. Let's see what else we can do. Well, we can do a show run here just to take a look that we should see. There's our port channel 2 right there, by the way. Okay, so that's good stuff there. Just a routed port. Okay, and again, let's go all the way down to gig 23 and 24. Okay, no switch port, no IP address, no switch port, no IP address, but they are both members of channel group 2. All right, what else do I want to take a look at here? Let's do show, this is a good one, show IP interface brief. Okay, so there's our port channel. It now has the IP address. State up and up. And if we come down here, we will see that gig 23 and 24 are state up and up, but they do not have the IP address. It's assigned to the port channel. Something else I want us to take a look at is that routing table again. Show IP route. And you'll notice, look at this. The directly connected interface, right? It's no longer showing the physical interface, it's showing the port channel, which is actually a combination of both physical interfaces. Okay. All right, the ultimate verification here. Let's do it. Okay, let's go with, can one of the PCs ping the other PCs? Let's go with PC2 here. And can PC2 ping PC8? So we're going over this ether channel here, up here, this ether channel, make sure it's all working, right? Okay, let's do this. Command prompt. Ping 10.30.2.102 from here to here. Okay. Now it's possible that some ARP requests might have to happen here. So it might, we might get 1 or 2 request timeouts. So just got to be a little patient here. There we go. Looking really good. All right, of course, if I did that again, then we shouldn't have any problem. All right, I hope you found this lab helpful, interesting, fun, kind of cool stuff, right? So we did both layer 2 ether channels, which avoids having spanning tree blocking one of the links, so we can utilize both links at layer 2. So we don't have to worry about loops. It's looked at as a single link. And we've done it layer 3. And layer 3, what this allows us to do, by the way, is allow us to use multiple links. So here I have 2 gigabit links, and I'm using but we think of sometimes twice the bandwidth between them. So as a single link. All right. Thank you. And I'll see you in the next lab.